What does it really mean for an AI to think? Today, we're diving deep into NoSQL databases, architecture for hyperscale data. Relational databases optimized for consistency now confront 100x data growth, real-time streams, and polymorphic data shapes. NoSQL delivers horizontal scale, schema agility, and tunable consistency, making it foundational for cloud-native architectures. Traditional RDBMS scaling requires complex sharding and denormalization, fracturing data integrity. NoSQL inverts this, distributed by design. Why now? The shift to microservices, event-driven systems, and AI feature stores demands a new persistence layer. NoSQL is the default data fabric for modern distributed systems. But here's where it gets interesting: the relational wall. Rigidity in a fluid world. SQL schemas enforce strict structure up front. Every schema change triggers costly migrations and downtime. ACD transactions, while safe, throttle throughput in distributed deployments. Vertical scaling hits physical limits. Horizontal scaling is bolted on and fragile. Polyglot data JSON documents, graph edges, time series gets forced into tables via object relational mappers, creating impedance mismatch and performance overhead. The result: development friction, performance ceilings, and data model mismatch. The industry needs native persistence for unstructured and semi-structured data at web scale. So what's the real problem? Let's talk about three forces reshaping persistence. Volume, petabyte-scale datasets from IoT, social, and logs. Velocity, millions of writes per second, real-time analytics. Variety, unstructured JSON graphs, key values. Relational databases were built for a world of structured, predictable OLTP. Sharding, replication, caching layers add operational complexity. Denormalization becomes a necessary evil, trading consistency for performance, but introduces data anomalies. The root cause: architectural assumptions of a single node. Strongly consistent world no longer hold. Modern workloads demand distributed first design with elastic scaling and native support for diverse data models. This raises a critical question: breakthrough, schema-agnostic, access pattern optimized. NoSQL discards the relational table abstraction. Instead, it offers data models shaped around access patterns, key value for simple lookups, document for nested objects, column family for wide rows, graph for relationships. Schema is optional or inferred, enabling rapid iteration. The data model is the API. Distributed storage and computation are built in, not retrofitted. Each model aligns storage layout with query topology, eliminating object relational impedance mismatch and enabling predictable performance at scale. Consistency models are tunable per operation, not globally fixed. Now let's zoom in on system architecture distributed by default. Client coordinator shard ring, consistent hashing, replicas, nodes, consensus, Raft, Paxos for metadata. NoSQL systems run on clusters of commodity nodes. Data is automatically partitioned and replicated. A coordinator routes requests based on partition key. Write-ahead logs, memtables, and SST-sables form the storage engine. Built-in failure detection and auto-rebalancing ensure resilience. The ring architecture maps hash ranges to physical nodes, enabling linear scale-out by adding nodes without downtime. Replication factor and consistency level are configurable per key space. Consensus protocols manage cluster membership and schema changes, while anti-entropy repairs maintain data integrity. Observability via metrics, tracing, and repair status is integrated. Here's something most people overlook: core primitives, partitioning, replication, consistency. Partitioning, hash-based key distribution, range-based ordered scans. Replication, leader-follower, multi-leader, leaderless, DIMA style. Consistency, tunable write, concerns, one, quorum, all, read repair, hinted handoff, anti-entropy Merkle trees. These primitives compose the data foundation. NoSQL allows operators to dial between latency, durability, and consistency per request rather than a fixed global setting. Compaction strategies, size-tiered leveled, merge SS tables, optimizing read performance. The secondary indexes map to distributed index tables. Tombstones handle deletes in immutable files. This granular control aligns system behavior with application SLOs. Think about this for a second. Write and read pipeline from request to disk. Writes, client coordinator, commit log sequentiable, memtable in memory, flush SS table compaction. Reads, coordinator bloom filter check memtable, SS tables merge return. Writes append to a commit log and an in-memory sorted structure. When memtable flushes, immutable SS tables are created. Reads consult a bloom filter, then merge data from memtable and SS tables. Compaction consolidates SS tables, discarding overwritten data and tombstones. SS tables are sorted by key for efficient range scans. Compaction strategies balance read-write amplification. The immutable file approach simplifies replication and crash recovery. And this is where things get complex. Data models by access pattern. Document, store and query JSON boson, flexible schemas for catalogs, user profiles, key value, simple put, extremely high throughput. Session stores, shopping carts, column family, rows with dynamic columns, time series events, sensor data, graph, nodes and edges, native traversals, fraud detection, recommendations. Each model removes the mapping layer, delivering performance proportional to hardware. Polyglot persistence uses the right model for each service. Choosing a data model aligned with query topology avoids expensive joins and translates directly to API response shapes. Schema evolution is online, no downtime. But here's where it gets interesting. Consistency spectrum, tunable guarantees. In a network partition, NoSQL systems choose availability or consistency. Eventual consistency allows high availability. Strong consistency uses quorum. A PAC-LC extends if partition choose between latency and consistency, else latency versus consistency trade-off. Write and read consistency levels, NNE1 quorum, all let developers define per operation durability. Consistency becomes a per-query parameter, not a database property. Multi-region deployment, local quorum for low latency, global quorum for strong integrity. This matches business requirements, eventual for likes, strong for inventory. So what's the real problem? Let's talk about impact. Developer velocity and elastic scale. NoSQL fuels continuous delivery, schema migrations without downtime. Horizontal scaling is linear. Add nodes for throughput and capacity. Multi-data center replication enables active-active global presence. Operational complexity shifts to the database, auto-sharding, repair, and scaling are built in. Teams focus on product logic, not infrastructure plumbing. Case. A social platform handles 1M writes XCC with aiding sends latency using Cassandra. IoT pipeline ingests 50 terabyte into DynamoDB. Fraud detection uses graph traversals in milliseconds. Mean time to recover from node failure, seconds. This raises a critical question. Future AI native and multi-model convergence. NoSQL is absorbing vector search, natively store embeddings and metadata in a single system. Graph databases integrate with graph neural networks for real-time inference. Multi-model databases unify documents, graphs, and key values under one query engine. HTAP fuses OLTP and real-time analytics. The distinction between operational and analytical databases dissolves. Serverless NoSQL with auto-scaling capacity removes provisioning. Data is accessed via familiar APIs, MQL, Gremlin, CQL while serving AI workloads natively. The database becomes a feature platform, not just a persistence store. Now let's zoom in on polyglot persistence as strategy. NoSQL is not a monolith. It is a family of engines optimized for specific shapes of data and access. The winning architecture selects the right tool for each domain: document for content, key value for sessions, column family for time series, graph for connections. Relational databases handle transactions where ACE ID is non-negotiable. Adopt NoSQL where it eliminates friction. Keep SQL where it provides safety. Designed for data shape, not for database dogma. The future is polyglot, distributed, and AI integrated. Your data layer must be as agile as your code.